Alleged bad design is evidence for design. It is not evidence for no design. In debates about intelligent design, atheists often point to what they see as examples of bad design in nature. Biological features or structures that are claimed to be inefficient, flawed, or suboptimal. Examples like the backward wiring of the human eye, the recurrent laryngeal nerve, or what seem to be wasteful processes in nature are often cited as evidence against the notion of an intelligent designer. The claim is incoherent and irrational, as we will show here. The atheist objection is based on several misunderstandings. In fact, alleged bad design does not argue against the idea of design at all. Here's why alleged bad design can actually strengthen the case for design and why it does not support the conclusion of no design. 1. The existence of a suboptimal design assumes design. When critics of intelligent design point to bad design, they are still operating within the framework of design. They are evaluating the efficiency or functionality of a system as though it had been intentionally arranged. This very act of assessing a design for its optimality or quality presupposes that there is a design to evaluate in the first place. You can't label something as bad design unless you first acknowledge that it is, in fact, designed. Key point. The very term, bad design, implies purpose, intent, and structure. It presupposes that the feature being critiqued has a certain goal or function and that the way it fulfills this goal is being evaluated. If there were no design at all, the category of bad design would not even make sense. For example, we don't speak of rocks, weather systems, or random patterns in nature as being badly designed, because we don't expect them to serve any specific purpose. Bad design, therefore, still points to the existence of intentional organization or design. 2. Design does not necessarily mean perfection. One common misunderstanding in the critique of intelligent design is the assumption that design must be perfect in order to qualify as design. However, this assumption is both philosophically and practically flawed. In many cases, what may appear to be imperfect or inefficient from one perspective has a valid explanation when the design is viewed within the broader context of complex systems and real-world constraints. Key point. Engineers and designers in any field understand that design often involves trade-offs. No design is perfect, even in human-made systems. Designers work within constraints, such as physical laws, available materials, and budgetary limitations, and aim for optimal solutions, not perfect ones. Biological systems are no different. Biological processes and developmental pathways impose constraints on how certain structures develop. What appears to be inefficient is often a compromise between competing needs. For instance, the backward wiring of the human eye, which is often criticized by atheists, has been shown to serve important functional roles, such as protecting photoreceptors and aiding light transmission. Similarly, the recurrent laryngeal nerve can be explained by developmental constraints related to the development of the adult from the embryo. In addition, these structures still serve their functional purposes efficiently. The fact that designs may exhibit imperfections does not negate the action of a designer. It merely reflects the reality of working within constraints, something even intelligent designers encounter. 3. Apparent imperfections can have hidden purposes. Many examples of alleged bad design have turned out to be misunderstandings based on incomplete knowledge of the system in question. What may seem like an inefficient or flawed design often reveals itself to be a well-adapted, functional solution when studied more deeply. This suggests that we should exercise caution before drawing conclusions about the adequacy of design based on superficial observations. Key point. The human eye is often cited as an example of bad design because the retinal cells face backward, causing light to pass through several layers before reaching the photoreceptors. However, further research has shown that the cells in question serve as a type of protective filter, preventing damage from ultraviolet light and providing crucial support to the photoreceptors. The design is not backward, after all, but is optimized for the conditions in which it functions. The appendix, long thought to be a vestigial organ with no purpose, has been shown to play a role in maintaining gut health and immune function by serving as a reservoir for beneficial bacteria. In both cases, what appeared to be poorly designed was actually a functional part of a larger system, revealing that our judgments about design often depend on incomplete knowledge. It is only with deeper investigation that the full purpose of certain features becomes clear. 4. Intelligent design in complex systems, trade-offs and constraints. Design in complex systems, whether biological or technological, often involves making trade-offs between competing priorities. This is true for human engineers and, for biological design as well. The existence of trade-offs does not indicate a lack of intelligence or purpose, it simply reflects the realities of complex systems. Key point. In engineering, a car engine may not be perfectly efficient because it needs to balance power output, fuel efficiency, durability, and cost. These trade-offs are inevitable in any complex system where multiple constraints are in play. In biology, similar trade-offs exist. For example, the cheetah is incredibly fast, but it sacrifices endurance for that speed. The gazelle is agile and fast, but not as fast as the cheetah. These traits represent biological trade-offs that allow both species to survive in their respective ecological niches. The fact that cheetahs are not perfect predators and gazelles are not perfect escape artists does not imply there is no design. Rather, it reflects the complexity of adaptive systems where balance is maintained through competing factors. The existence of trade-offs in biological systems is consistent with the idea of intelligent design and does not negate the presence of purpose or function in those systems. 5. The problem of evaluating design without purpose. Critics of intelligent design often evaluate biological structures without considering what the purpose of the design might be. They impose human standards of efficiency or optimality without understanding that biological systems have different goals than those presumed by the critic. For example, survival, reproduction, and resilience may take precedence over efficiency in many biological systems. Key point. To criticize design effectively, one must first understand what the design is trying to achieve. For example, in biological systems, the goal is often not efficiency but robustness, redundancy, or resilience. Systems that seem inefficient are actually optimized for survival in harsh, unpredictable environments. Redundancy in biological systems is often essential for resilience. While redundancy may seem wasteful from a pure efficiency standpoint, it is critical for long-term survival. For example, many organisms have backup systems or fail-safes to ensure survival if a primary system fails. Therefore, what is perceived as inefficient is often perfectly suited to the biological purpose it serves. This perspective should be considered before concluding that any apparent inefficiency implies a lack of design. 6. Conclusion. Bad design is still evidence of design. In conclusion, alleged examples of bad design in nature do not disprove intelligent design. In fact, the very act of labeling something as bad design presupposes the existence of design. Criticisms based on perceived inefficiencies often rest on misunderstandings of how complex systems work or incomplete knowledge of biological structures and their purposes. Design is not synonymous with perfection, and even in human-engineered systems, trade-offs and constraints are common. Biological systems are no different. What appears as inefficient or flawed, upon deeper inspection, turns out to be a functional solution optimized for survival, resilience, or adaptation. In the end, the presence of design in nature, whether perfect or imperfect, points to a rational mind behind the complexity of life. Bad design does not argue against design, it simply highlights the complexity of the design process in a world governed by laws of nature, developmental constraints, and adaptive dynamics. Far from disproving intelligent design, the presence of complexity, both good and bad, is consistent with the idea that nature is the result of purposeful planning. Thanks for watching. Please like, share and subscribe, and comment below if you agree or would like to add your thoughts. If you would like me to respond to your comment, please make a level 1 comment directly below the video. I will respond to all polite level 1 comments even if it takes me a while, due to other commitments.